my YouTube channel. In the previous classes, we have studied about the electronic configuration in groups and the pairs. Today, we are going to learn about the types of elements. Now, let's understand how elements are classified into different blocks of the periodic table. Elements are divided into four blocks: the S block element, P block element, D block element, and F block element. The classification is based on the subshell into which the last electron enters in the ground state electronic configuration. Let's discuss each block one by one. Okay, so first block is S block element. So the S block element consists group 1 and 2. Okay, here's the last electron enters the S subshell. Okay, so the general electronic configuration is NS1 to NS2. Okay, so this block includes the alkali metal and the alkaline earth metal. Next is P block element, which includes the group from 30 to 18. Okay, the general electronic configuration of P block element is NS2 and P1 to 6. Okay, this block contains most of the non-metal, metalloids and the some metal. Okay, now let's move to the D block element, which includes the group from 3 to 12. Okay, so the general electronic configuration is N-1, P1 to 10, NS1 to. So the elements are known as a transition elements because they show transitional properties between the S block and the P block element. Okay, and the last electron enters in N-P subshell. Okay, finally we have F block element. In this element, the last electron enters N-2 F subshell. The general electronic configuration of P block element is N-2 F1 to 40, N-1D 0 to 1, NS2. Okay, so the F block consists lanthanides and the actinides. This element is also called as the inner transition element. Okay, they are placed separately at the bottom of the periodic table to keep the table compact. Okay, let's discuss the location of block in the modern periodic table. Okay, if you look at the modern periodic table, the S block is on the left side of the periodic table, right? And the D block is in the center and the P block is on the right side. Okay, so the F block is placed below the main table. Okay, this is the F block element. Okay, so this is the lanthanide and the actinide of the F block element. This is the 4F series and the 5F series, which is also called as the inner transition element. Let's see a few examples. Sodium. Sodium has the electronic configuration Ne3S1. Okay, so it belongs to the S block element. Silicon has a Ne3S2 and the 3P2. So it belongs to the P block element. Next is iron, that is Fe, has Ar3D6 4S2. So it belongs to the D block element. Cerium has a electrons entering the 4F subshell. So it belongs to the 4F block element. Okay. So you have to remember some important points of this slide. Okay. So the position of an element, in the periodic table, depends on its electronic configuration. Okay. Second point is the block of an element is determined by the subshell. The block of an element is determined by the subshell that receives the last electron. Okay. Third point is D block element is also called a transition element. Okay, the D block element is also called a transition element. Okay. Next point is F block element is also called inner transition element. The F block element is also called as a inner transition element. The easiest way to identify the block of any element is to look at the subshell in which the last electron enters. Once you know that, you can immediately tell whether the element belongs to S, P, D or F block element. Okay, so these are some important points of this slide. Now let's understand how elements are classified based on their physical and chemical properties. The elements in the modern periodic table are broadly divided into three categories. Okay, that is metal, non-metal and the metalloids. Okay, let's discuss each one. So first is metal. Okay, so mostly found left side of the periodic table. Metals are mostly found on the left side of the periodic table. Okay, so they are good conductor of heat and electricity, which is why they are widely used in the electrical wires and some cooking utensils. Okay, next point is malleable and ductile. Metals are malleable, meaning they can be hammered into thin sheet, and ductile, meaning they can be drawn into wires. Okay, next point is lustrous, means shiny appearance. They have a lustrous or a shiny appearance and generally have high melting and the boiling point. Okay, so chemically metals tends to lose electron and form a positive ion called as a cation. Some example of metals are sodium, magnesium, aluminium, iron, copper, zinc and silver. Okay, next is non-metal. Now let's discuss non-metal. Okay, so non-metals mostly found on the right side of the periodic table. Unlike metals, they are a poor conductor of heat and electricity. If they are solid, they are usually brittle, meaning it breaks easily. Okay, they are generally dull in appearance and usually have a lower melting and boiling point. Chemically, non-metal tend to gain electron and form a negative ion called as a anion. Okay, example of non-metal is hydrogen, carbon, nitrogen, oxygen, phosphorus, sulfur, chlorine and the iodine. Next is metalloids. Okay, so between metal and non-metals we have a metalloids. Metalloids are found along the zigzag or the staircase line in the periodic table. Okay, so this is the zigzag line. Okay, so these are some metalloids in the periodic table. Okay, so they show properties of both metals and the non-metals. Okay, most metalloids are semiconductor of electricity, which makes them extremely useful in electronic devices such as computer, chips and the mobile phones. Okay, they are generally hard but brittle and show intermediate chemical behavior. Okay, now let's discuss the location in the periodic table. If we observe the periodic table carefully, metals occupy the left and the center. Okay, so blue is the color of metal. So blue color occupy at the left side and the center of the periodic table. Non-metals are located on the right side of the periodic table. Metalloids lie along the staircase line separating metals from non-metals. Noble gases are present in group 80. Okay, so this is noble gas group 80. Okay, noble gases are present in group 80 on the extreme right. Okay, so these are noble gases. Okay, trends in metallic character. Now let's understand an important trend of the periodic table. Across the period from left to right, the metallic character decreases because elements become less likely to lose electron. On the other hand, while moving from top to bottom in a group, the metallic character increases because atoms lose electron more easily. Okay, so you have to remember some important points of this slide. Metalloids have properties intermediate between the metals and non-metals. Okay, metalloids have properties intermediate between metals and non-metals. Okay. Second point is the physical and chemical properties of elements are closely related to their electronic configuration. The physical and chemical properties of element are closely related to their electronic configuration. Okay, so these are some important points of this slide. Now let's discuss one of the most important topics in the periodic table, that is periodic trends in properties of elements. Okay, the physical and chemical properties of elements do not change randomly. They show a regular or a periodic variation because of the periodic change in atomic number and electronic configuration. Okay, let's study each trend one by one. First is atomic radius. Atomic radius is the distance from the nucleus to the outermost electron shell. Across a period from left to right, the atomic radius decreases because the nuclear charge increases and pulls electron closer to the nucleus. Down a group, top to bottom, the atomic radius increases because new electron shells are added. So remember, across a period, atomic radius decreases and down a group, atomic radius increases. Next is ionic radius. The ionic radius depends on whether the ion is a cation or an anion. A cation is smaller than its parent atom because it loses electron. An anion is larger than its parent ion because it gains electron. The trend is across a period, the ionic radius generally decreases and down the group, the ionic radius is increasing. Okay. Next is ionization enthalpy. Ionization enthalpy is the energy required to remove the outermost electron from an isolated gaseous atom. Across a period, it increases because the atomic size decreases and electrons are held more strongly. Down a group, it decreases because outermost electron is farther from the nucleus and is easier to remove. Next is ionization enthalpy. Ionization enthalpy is the energy required to remove the electron from an isolated gaseous atom. Across a period, it increases because the atomic sizes decreases and electrons are held more strongly. Down a group, it decreases because outermost electron is farther from the nucleus and easier to remove. So, across a period, ionization enthalpy increases and down a group, ionization enthalpy decreases. Next is electron gain enthalpy. Electron gain enthalpy is the energy change when an atom gains an electron. Across a period, it becomes more negative, which means atoms have a greater tendency to gain electrons. Down a group, it becomes less negative. Remember, noble gases usually have positive electron gain enthalpy because their valence shell are already completely filled. Okay. Next is electronegativity. So what is electronegativity? Electronegativity is the tendency of an atom to attract the shared pair of electrons in a chemical bond. Across a period, electronegativity increases and down a group, electronegativity decreases. Okay. This is why fluorine is the most electronegative atom. Next is metallic and non-metallic character. Metallic character means the tendency of an atom to lose electrons. Across a period, the metallic character decreases because the atom holds their electron more strongly. Down a group, the metallic character increases because the atom loses electron more easily. On the other hand, the non-metallic character show the opposite trend. Okay, it increases across a period and decreases down a group. Okay. So next is the direction of trends in the modern periodic table. If you observe the modern periodic table carefully, atomic radius increases toward the bottom left. Okay. And the ionization enthalpy and electronegativity increases toward the top right. Okay. And the metallic character increases toward the bottom left. And the non-metallic character increases toward the top right. Across a period from left to right, the atomic radius decreases and down a group from top to bottom, the atomic radius increases. Next is ionization enthalpy. Ionization enthalpy increases in a period and decreases in a group. Electron gain enthalpy more negative in period and less negative in a group. Electronegativity increases in a period and decreases in a group. Metallic character decreases in a period and increases in a group. Right. And non-metallic character increases in a period and decreases in a group. So this is all about the types of elements and the periodic trends in properties of elements. Okay. That's all for today's class. We will continue in the next class. Until then,